Turning low-grade ore into the most used metal in the world starts in a 200-foot tall furnace. This is where the iron ore is hit with heat generated by a type of fuel called coke.
Coke is the result of burning the impurities and the junk out of coal that you don't need to get to the good stuff, which is going to burn cleanly and give you the nice, hot, clean fire that you need to make steel.
It's called the blast furnace because as the ore and coke flow downward, they're met by a 1,600-degree blast of hot air moving at 110,000 cubic feet per minute.
The wind is coming in at what we call the Bosch level of the furnace through nozzles, which are called tweers, and we have 18 of them depending on the size of the blast furnace. That air is pushing up through a solid burden material.
The superheated air ignites the coke like charcoal in a grill and heats up the furnace to nearly 4,000 degrees Fahrenheit. At this temperature, the oxygen is finally blasted away, leaving pure molten iron. But it's also doing something even more amazing. As the heat from the coke flame strips away the oxygen, the carbon in the coke is bonding to the iron.
You have hot blast going in, you have the material going in at the top of the furnace, and it's melting, and as it's melting, it's going down.
Under the extreme heat, the mixture liquefies. Impurities like silica and sulfur rise to the top. The heavier iron sinks to the bottom, where it's drawn out in a glowing molten stream.
The furnace until it turns into liquid, and it comes out the tap hole.
Every 45 minutes, some 500 tons of molten metal, called pig iron, gushes from the tap. It's called pig iron because it was originally cast into molds resembling piglets suckling a sow. But ironically, though the iron has been freed from the oxygen, the molten pig iron that flows from the furnace has a new problem: too much carbon. Over 4%, which makes the resulting metal much too brittle. To become steel, that number needs to be reduced to less than 2%.